Okay, to solve this question, first think about tan inverse of x equal to y. Another way to think about this is you can apply the tangent function both sides. Like that. And whenever you compose an inverse function with itself, they cancel each other. So you have x equal to tangent 1. So you can go from here to there by thinking of the inverse function as switching input and output, or another way to think about it is apply tangent both sides so that the left side function cancels away and then you get that. Okay. Whatever you do, this should bring you down to here. Now you differentiate both sides. And that gives you left side as 1, tangent differentiate to secant squared times y. Y prime, thank you. And then this appears because you're pulling the inside function out. Y is a function of x, therefore when you differentiate you have to use the chain rule. That's why you have to pull this out and differentiate. And I'm going to divide both sides by secant squared of y. So that I get y prime equals to 1 over secant squared of y. Okay. However, this is not so satisfactory because we have answer in terms of y, but the original question is just posed with x, and y is something that we introduced in order to solve it. Okay. So we need to do further calculation from here. One thing we can do is we can simplify this right side by remembering that 1 over secant is equal to cosine, right? So 1 over secant squared will be cosine squared of y. And then this means, this really means what? That really means cosine of y squared. So we need to figure out what cosine of y is. How do we know that? Well, we get it from here. Since tangent of y is equal to x, think about this as x over 1. And from SOHCAHTOA, tangent is opposite over adjacent. TOA, SOHCAHTOA. So tangent of an angle y is opposite over adjacent. So opposite, at the opposite you see an x here. At the adjacent you see a y here. 1 here. Okay? And the only thing that we do not know is this hypotenuse, which can be, again, calculated by the Pythagorean theorem, right? How do you use the Pythagorean theorem? 1 squared plus x squared. Square root is this side, so it's a square root of 1 plus x squared. Okay, so from here, we're almost arriving at the answer because cosine of y, again using SOHCAHTOA, cosine is 1 over what? Adjacent over hypotenuse. So adjacent is 1 divided by the hypotenuse. And you put it back in here, and your final answer is 1 over square root of 1 plus x squared squared, which is 1 over 1 plus x squared. So that's the derivative of tangent inverse of x. All right, let me also give you the derivative of the cosine inverse. You use the same idea. You say cosine inverse of x is y, so that x is cosine of y. Differentiate both sides. X differentiates to 1, cosine differentiates to negative sine of y, and then you pull the inside out and differentiate, so it's y prime, which means y is negative 1 over sine of y. Now since cosine y is x over 1, and cosine is adjacent over hypotenuse, adjacent is x, hypotenuse is 1, and if you use the Pythagorean theorem, we can see that this other side is 1 minus x squared. And therefore, what is, by the way, if you say this angle is y, therefore, what is the sine of y in this picture? It's opposite over adjacent, opposite over hypotenuse. So this is equal to negative 1 over square root of 1 minus x squared. And that's how we get all the trig functions. So let me summarize it here. Summary. Sine inverse of x prime is 1 over square root of 1 minus x squared. Cosine inverse of x prime is negative 1 over square root of 1 minus x squared. And tangent inverse of x prime is 1 over 1 plus x squared. Now keep in mind that these have other names too. Some people call, instead of this sine inverse of x, people call sine inverse of x as arcsin. Okay. Cosine inverse is called arccosine, and tangent inverse of x is called arctangent of x. So sometimes the formula could be read: the derivative of arcsin prime is 1 over square root of 1 minus x squared, and so on and so on. So that's how you should know these formulas. You have to remember these formulas because you can again be asked the derivative questions involving the inverse sine functions. Okay. Now let me show you just one more interesting thing before I give you some other questions involving inverse trig functions. Just one more interesting thing. Find arcsine of x plus arccosine of x prime. What does it mean? Let's think about the following question. Okay, this is a rather simple question. Arcsine of x, differentiating the sum is differentiating each individual ones. What's the derivative of arcsine? 1 over square root of 1 minus x squared. What about this?
Same thing.
But it's the same thing with the minus sign, right? So what's the end result? It's equal to 0. Okay. Now, if something differentiates to 0, what can you say? It must be a constant. Actually, that statement requires a proof, but it's actually true. I don't want to show you the proof now, but it's true. So, if you differentiate something and get 0 as the result, that means the original thing that you started with is actually a constant. Right? So, this calculation actually tells us that if you add arcsine x and arccosine x together, you're going to get a constant value. So this means arcsine of x plus arccosine of x is a constant. Can anybody think about what constant this is? What is the actual value of this constant? Yes?
Is that the same as sine squared plus cosine squared?
No. It's, that one is also constant, but it's not related to this. I mean, think about this. If it's a constant, then it should give you the same value when x is equal to 0, right? So we can think about this constant as the value of these functions when x is equal to 0. Okay, when is sine equal to 0? At what angle? Sine of 0 is 0. No. Sine of 0 is 0. So arcsine of 0 is 0. Cosine of what is equal to 0?
Andy.
Is that right? Just a minute. Yeah, that's cosine, right? Like that. So it's pi. So at pi over 2, it's equal to 0. So cosine inverse of 0 should give you pi over 2. Okay, so we learned something today that if you add arcsine of a value plus arccosine of a value, the value of the sum will always be equal to pi over 2. This really comes from the following identity. If you're curious to know why this is so, this really comes from the following identity. There's something called the Cofunction Identity, which is sine of pi over 2 minus theta is equal to cosine of theta. So from here, this is kind of, this implies that. So think about that. Yes?
What if you use all the other spots that are equal to 0 for sine?
Oh, yeah, that's a good question. So I said arcsine of 0 is 0, but if you look at the sine graph, there are several other spots when sine is equal to 0. So the question is, why do we use 0? Why not pi or 2 pi? That's because arcsine is not the inverse function of the sine function, but it's a restricted sine function is the inverse function. So you first restrict the sine so that it's 1-to-1 inside this domain. And then only from here you're trying to find the inverse value. Okay, so that's why this is 0. Yes?
Why is sine restricted in that interval only? Is it different for cosine's interval? Is it restricted?
Cosine, you have to restrict it from 0 to pi. Do you remember that in order to have an inverse function, it has to pass the horizontal line test to be 1-to-1? If you take the entire thing, then it doesn't pass the horizontal line test. So you restrict it to a certain domain, which does pass the horizontal line test. For the cosine, you don't want negative pi over 2 to pi over 2, because then it's going to fail the horizontal line test. So you restrict the domain from 0 to pi, and then you take the inverse. That's the inverse cosine function. Here, the sine, you restrict it from negative pi over 2 pi over 2, because over there, it's 1 to 1. You should read about the inverse sine and cosine functions.